Today we're looking at notes 8-1, polynomial and behavior. It's actually one of the neatest lessons in Algebra 2, I think. So the degree, I'll remind you, is the highest exponent on the variable. So if the degree of the polynomial is even, if the highest exponent is even, the end behavior or arrows face in the same direction. What I mean by that is the quadratic, y equals x squared. The degree, the highest exponent, is even. On any quadratic graph, whether it opens up or down, both arrows face in the same direction. They both either face up or they both either face down. If, however, the degree, the highest exponent, is odd, the end behavior or the arrows face in opposite directions. For example, a linear graph. Okay, a linear graph has highest exponent of 1. 1 is odd. So the arrows on either end of the graph face in opposite directions. One's down, one's up. Okay. The degree also tells you how many turns the graph can take. So if you take the degree and subtract 1, that tells you the maximum number of turns the graph can take. For example, if I look back over at this quadratic graph, the degree is 2. If I take 2 and subtract 1, that would be 1. 2 minus 1 is 1. And this graph does have one turn on it. It humps once, just one little hump there. Okay. The leading coefficient, now we're only talking if the polynomial is in standard form. Okay, the leading coefficient, if the polynomial is in standard form, can also tell you a lot. If the lead coefficient is positive, then the right end behavior, or in other words, the right arrow, is up. Okay, for example, my leading coefficient here, y equals 2x, is positive. That number in front is positive. My right arrow on my graph goes up. That makes sense. A positive slope, the right arrow goes up. If my lead coefficient is negative, my right arrow, my right end behavior, is down. So for example, the lead coefficient here is -2. My right arrow is down because the lead coefficient is negative. Okay, we use very specific notation that will help you in pre-cal and calculus for this. So we say as x approaches, that's what that arrow means, as x approaches negative infinity, so we're talking on the left, as x goes to negative infinity, f of x, so in other words y, what do our y values do? Our y values go, well, do they go to positive infinity or do they go to negative infinity? Likewise, as x approaches infinity, so on the right, what's happening on the right side of the graph? F of x does what? So what are the arrows doing? Are they going up or are they going down? Okay, so let's look at some examples to go with this. So given this polynomial, f of x equals -x⁴ plus 5x cubed minus 1. First thing I'm going to have you look at is the degree. So the degree of this polynomial is 4. That tells me two things. 4 is even. Okay, 4 is even. That means the arrows will face in the same direction. That means same direction for the arrows. Okay, that's what the even degree means. Okay, also the degree minus 1, so 4 minus 1 equals 3. That tells me how many turns this graph can take, up to 3 turns. Okay, and then the leading coefficient, so is this in standard form? Yes, it is, descending powers. Okay, our leading coefficient, I'm going to abbreviate that LC. My leading coefficient is -8. -8 is obviously negative. A negative leading coefficient means my right arrow goes down. Okay, so we can go ahead and draw a rough sketch based on this information. So we know our right arrow goes down, so I'm just going to draw a downward facing arrow. We know in between here to the other side, going backwards, there's 3 turns. We also know that because my degree is even, my arrows face in the same direction. So if my right arrow goes down, my left arrow must also go down. And I know that in between here I have 1 hump, 2 humps, 3 humps, because that's what it says, 3 turns. Okay, so now that I've got my rough picture, it's easier, I think, to do the notation. So let's go ahead and do the notation. As x approaches, okay, negative infinity. So on the left, as x goes to the left, my y values, f of x, what do? So on the left, this graph is going down. Oops, that doesn't look much like an arrow. My y values go down. They go to negative infinity. Also, as x approaches, so on the right, infinity, f of x approaches negative infinity. My arrow is going on the right, my arrow is going down to negative infinity. Okay, let's look at another example real quick here. So given this equation, f of x equals negative x plus 2x cubed plus 5. I notice right away that's not in standard form, so I'm going to fix that. I say it needs to be written 2x cubed minus x plus 5. Okay, so now that I've got it in standard form, I'm going to look at the degree. The degree here is 3, and 3 is an odd number. Okay, a degree being odd tells me the end behavior or the arrows face in opposite directions. So odd, opposite. That's how I think of that. Odd, 3 is odd. That means arrows face in opposite directions. Okay. Also, I know the degree, 3 minus 1 is 2, and 2 tells me the number of turns. Okay, last thing, my lead coefficient, my LC, my lead coefficient is 2. 2 is a positive number. Positive leading coefficient tells me my right arrow is up. Okay, so right there I can start my graph. My right arrow is up, my sketch. Okay, I know that my arrows face in opposite directions, so if this one goes up, my left one must go down. Okay, I also know there's 2 turns in between, so that would be 1 turn, 2 turns. Okay, so then from my picture, it's easy to see as x approaches negative infinity, so we're talking about left, my f of x, my y values, go down. On the left, my arrow is going down, negative infinity. However, as x approaches positive infinity on the right, f of x, my y values, approach positive infinity. My graph is going up on the right. Okay, so that's enough about end behavior there. Let's talk about more things that we can find about polynomials, and in this case, given a table. So you can use differences to determine the degree of the equation. So given a set of values, and you'll notice this is a specific set of values. My x values go from -3, -2, -1, 0. So from each x value to the next, I'm only jumping by 1. Okay, so this is going by 1. I'm adding 1 every single time to get to the next x value. What you're going to do is find the difference between the y values. So what I mean by that is, what is the difference from -7 to from -1 to -7? So you will go backwards and subtract. -7 minus -1. -7 minus -1, that would turn positive. That would be -6. Okay? Going from -3 minus -7, that would give me -3 plus 7, which would give me 4. Okay? 5 minus -3 will give me 5 plus 3, which would give me 8. 11 minus 5 would give me 6. 9 minus 11 would give me -2. -7 minus 9 would give me -16. Okay, so what you're looking at after you find the difference of the first set of y, then you look at these numbers. Do they match? Well, definitely not. So then find the next difference. So 4 minus -6. 4 minus -6 is 10. 8 minus 4 is 4. 6 minus 8 is -2. -2 minus 6 is -8. -16 minus -2 is -14. Again, my next set of differences don't match, so moving on. 4 minus 10. 4 minus 10 is -6. Okay, -2 minus 4 is -6. -8 minus -2 is negative 6. Negative 14 minus negative 8 is negative 6. What this tells me, these numbers all match. This tells me my first difference was here. My second difference was here. My third difference was here. My third difference is what matches. That tells me this polynomial with these points is third degree. Isn't that neato? Okay, last thing I want to show you, another little attribute I want to show you about polynomials. Let's look at stating the relative max and relative min of the graph. So this is a calculator skill, really. Okay, so if I type this into the calculator, I've gone ahead and already done that. I type this into the y equals of the calculator, and when I graph this, I know, okay, first of all, this doesn't really show us a whole lot. It's kind of hard to see. I know this is cubic, it's third degree. Third degree means the arrows face in opposite directions, and they do. You can kind of see it here. I also know the leading coefficient is positive. That means the right arrow goes up, and so the left arrow must go down. So basically, essentially, this is what this graph looks like. But with this on my calculator, it's really hard to see the up top here and the down low here. These two humps, as you may, are called the relative max of the graph and the relative min of the graph. Okay, and we can use the calculator to find what those y values are. So if you get a graph something like this, what you're going to have to do is really adjust the window. This doesn't go high enough y value wise, and it doesn't go low enough y value wise. So I'm going to go to the window, and my y min says negative 10. I definitely want to take it down to at least negative 30, I'd say. My y max, let's put that at positive 30 and go back to the graph. Okay, I definitely still didn't go high enough, but look at that. I went low enough. I can see my relative min here. So my relative max, I've still got a long way to go. So I'm going to go back to the window, and I'm going to double it. I'm going to say 60. And you know what? That might not even be enough, so I'm just going to go with 80. Wow, barely. Okay, so now I can see my relative max, my relative min. And it's really nice. There's a button on the calculator. After you've adjusted the window, you go to second trace. And what you want to find first, let's just do the max first. Max. See how here it says left bound. My cursor is flashing here. I want to go to the left of this max. So I'm trying to push that blinking cursor to the left of my max. So see it? It's to the left of my max. I hit enter. Now it wants me to go to the right of my max. I'm moving it. I hit enter. I hit enter again. And it's saying my relative max is at negative 3.99999, so about negative 4, comma, my y value is 80. So my relative max is at y equals 80. And my relative min, let's go ahead and find that, is at y equals, let's see, go to second trace. Now we're looking for the min, enter. I'm going to my cursor is flashing way up here. I want to go to the left of my min. So I want to go about there, hit enter. I want to go to the right of it. It's flashing, hit enter. See how up there I've got my arrows somewhere between here and there. Down below there's my relative min. I hit enter again because I want it to guess. And my y value of my relative min is at negative 28. You could also kind of use the table. It is more time consuming sometimes to see, especially because those are just your relative max and min. You know, the graph does go lower than this, but it's over here. So you have to be really careful when using the table. The graphing feature is much easier.